Hi, my name is Jack Elvy, and this is my fourth year engineering project, which involved investigating and mapping geotechnical soil layers in Rotorua. So this project essentially picking up from where a report in 2010 by GNS Science left off, which identified large areas of Rotorua as potentially containing soft soils. So this report was done for the Rotorua Lakes Council, who wanted to know the location of soft soils as they proved problematic for construction. So this investigation was based pretty much entirely on the geology of the area. They used data from 5 investigations to actually confirm whether their zoning was correct. But for the large part, the zones were not, they didn't actually have any data put to them. So since 2010, there's been a lot of testing done in Rotorua. So this investigation aims to essentially put the data and create some maps and either confirm or redefine these zone boundaries. So the data come from primarily 2 geotechnical tests, the cone penetrometer test and the scalar penetrometer test. So both involved pushing a steel tip into the ground and monitoring the resistance of the soil to the tip going to the ground. In the case of the CPT, it comes with a sleeve and a piezometer, which allows for the measurement of sleeve friction and pore water pressure, which in turn means you can calculate a whole bunch of geotechnical parameters in addition to just soil resistance. So the background on how these soils came to be in Rotorua, primarily attributed to 2 things, which is the rise and fall of the lake over the last 40,000 years and historical outlets associated with lake levels when they were higher. So the map there shows the lake levels over the last 40,000 years. The red outer one shows that at one point, pretty much the whole of the Rotorua residential area was underwater. And this next map here shows that there were 3 historical outlets coming from the lake at some point. So because of these, we expect to find loose sediment deposited quite high up the Rotorua Basin and in the valleys leading out of it. So the method for collecting the data. So all of the data used in this project came from the New Zealand Geotechnical database. So this database was set up just after the Canterbury earthquakes, when there was a whole bunch of testing being done in the region, and there was a need for this information to be made publicly available. So just to really assist with the Canterbury rebuild. So this database was extended for the whole of New Zealand, and since then there's been a lot of testing uploaded for the Rotorua section as shown in the map there. So in order to model this data, 2 modeling softwares were used, which are Leapfrog and ArcMap, which is a component of ArcGIS. So Leapfrog allows 3D modeling of borehole data. So boreholes are essentially when you drill into the ground and you retrieve samples, and you identify soil layers using those samples. Unfortunately, boreholes are not as commonly used as cone penetrometers, and as such, there's not that many of them on the database. However, there are lots and lots of cone penetrometer tests available. And using cone penetrometer data, you can identify soil layers using the graph there, which places them into one of 9 zones. So using Leapfrog, data from 154 CPTs was uploaded to a model, Rotorua. Shown in the picture there is an extract of the model showing Kawa Point in Kotu and the 5 CPTs available for this area. So unfortunately, because the area covered was so large and the data was so scarce, Leapfrog was not able to interpolate the soil layers between the CPTs. Therefore, in regards to this investigation's overall objective, wouldn't prove very useful. However, Leapfrog does show good potential for modelling soft soils and just any soil layers really over a small area using CPT data, such as for a subdivision. ArcMap, however, has been used worldwide to do this exact project, where you input data over a large area and interpolate the data on a 2D map of an area. So shown on the picture there is a map showing the depth of groundwater level throughout Rotorua, using those same 154 CPTs found on the database. So the map shows a trend which was expected, in that the groundwater is deeper in high elevations around the outside of the Rotorua Basin, and shallower as you get closer to the lake. You can also see the valley between the two areas of deep groundwater, which aligns with one of the historical outlets of the lake outlined previously. So the map for groundwater level was prepared prior to any other parameters, because as mentioned before, we know what the trend should be. So it was a good way to check the accuracy of ArcMap. So still, the work that's still ongoing in this project is mapping cone resistance, which will indicate whether a soil deposit is soft or not. So the intervals chosen for the modelling is 0 to 1 meters, 1 to 2 meters, and 10 to 12, and 12 to 14 meters. So these intervals were chosen because this is where the report by GNS Science identified the depth most likely to find soft soils at. So in addition to plotting cone resistance, the geotechnical parameters outlined in the table there will also be mapped, because these are the parameters most commonly used in foundation design, and as such can provide wide guidance on where or what type of foundations you may be expected to build in different areas of Rotorua. This will also tie in with the work that 2 other students are doing on foundation design as well. Once the work's completed, it is expected that these GIS layers will be able to be sent to the council and they can upload it to their database. So finally, acknowledgements. I'd like to thank Kim de Graaf for being a really helpful supervisor, and your mentorship has been much appreciated. So that's my 4th year project. Thanks for listening.